Some machines refuse to break. They're built with incredible precision. They keep running decade after decade, long after their makers are gone. From century-old engines to one-of-a-kind clocks, here's 15 machines that are still running after 100 years. Starting with number 15, the Centennial Light Bulb, 1901 to present. Hanging quietly from the ceiling of Fire Station Number 6 in Livermore, California, it's one of the longest-running machines ever built, a single carbon filament light bulb that's been burning almost continuously since 1901. It's known as the Centennial Light. It's been verified by the Guinness World Records and Ripley's Believe It or Not as the world's longest-lasting operational light bulb. Now, the bulb was manufactured by Shelby Electric Company of Ohio sometime in the late 1890s. It uses hand-blown glass and a thick carbon filament. These are materials typical of early incandescent bulbs. Unlike modern tungsten filaments that run extremely high temperatures, the Shelby bulb operates at a lower temperature and produces a faint orange-amber glow, and consumes only about 4 watts of power. That lower heat output is the primary reason for its survival. The filament doesn't really evaporate as quickly, and the internal vacuum has remained intact for more than 100 years. According to the station's records, the bulb was first installed in 1901 at the Livermore Fire Department's original station on L Street, and when the department moved buildings in 1976, the bulb was carefully transferred with its power source still running, escorted by police and local electricians to avoid disconnecting it for too long. Since then, it's glowed almost uninterrupted with only short power outages and maintenance transfers. Tests performed in the 1970s by General Electric engineers and the Illuminating Engineering Society all confirmed that it was an original Shelby bulb and that the filament was still structurally intact. In 2015, a digital power monitor was added to log any interruptions, confirming that the bulb had continued burning for more than 1 million hours. Today, you can view the bulb through a webcam, and at the small Centennial Light Bulb Museum adjacent to the firehouse, it is a point of civic pride for the city of Livermore, and it is a living artifact of early electrical history. This warm, dim light serves as a literal and symbolic reminder of how enduring simple, careful engineering can be. It's an invention from another century that has never stopped running. Number 14, the Zettler Clock. In the center of Munich, a 19th century electric clock designed by Johann Baptist Zettler still ticks inside the St. Michael's Church Tower more than 130 years after it was installed. Built in the 1880s by Zettler's Workshop, one of Germany's earliest makers of electric timekeeping mechanisms, this clock is a transitional moment between traditional pendulum systems and early electrical engineering. Its main movement is powered originally by a weight-driven escapement that was converted to electric impulses in the late 19th century. That was a design Zettler pioneered. A small electromagnetic coil delivered timed impulses to keep the pendulum oscillating with exact rhythm, and this system required little lubrication, and because the coils replaced many mechanical gears, the wear over time has been minimal. Maintenance records show regular cleaning and rewiring, but no major component swaps since the early 20th century. The timekeeping accuracy is within a few seconds per week, which comparable to modern mechanical tower clocks. The electrochemical contact system, the tiny platinum points that open and close, still operate using the original design. The Zettler company was later absorbed by Siemens. They produced only a limited number of these early electric clocks, and very few survive. The Munich example has been verified by both horologists and electrical historians as one of the oldest continually operating. Unlike later synchronous or quartz systems, it depends only on gravity, basic magnetism, and precision metalwork. No electronics or even fragile wiring. Its brass bearings and pendulum assembly were built with generous tolerances, allowing for expansion and contraction through decades. The wooden case housing the master pendulum has remained sealed against dust and moisture. For more than a century, the Zettler clock has kept time for churchgoers, historians, and tourists without interruption. While modern digital clocks might outnumber it, few can claim a record of uninterrupted service like this one. More than 130 years after it began ticking, this clock still runs every day, quietly proving that 19th century engineering executed with care can outlast almost anything built since. Number 13, the Laxey Wheel, 1854 to present. Standing above the village of Laxey on the Isle of Man is a massive red and white water wheel that's been turning for more than 160 years. It's known as the Laxey Wheel, or Lady Isabella. It was completed in 1854 to pump water from the island's Great Laxey Mine. It still remains one of the largest working water wheels in the world and one of the oldest mechanical machines still operating in its original form. The wheel measures about 72.5 feet in diameter and 6 feet wide. It was designed by engineer Robert Casement and named after the governor's wife, Lady Isabella Hope. Originally, the wheel powered a series of rods and cranks that stretched over 600 meters underground to pump water from the lower mine levels, and that system required no external fuel or electricity, only gravity and flowing water. When the mine closed in 1929, the wheel was preserved as a historical monument, and restoration efforts kept it functional. Today, it continues to spin daily during the tourist season, driven by the same water system that sustained it since Victorian times. Periodic restorations, most notably in 1989 and again in 2022, focused on replacing corroded iron fittings and decaying timber, but the original mechanism is intact. Engineers have confirmed that much of the gearing, crankshaft assembly, and bearing structure date to the original 1850s build. Today, it serves as a heritage landmark and an example of pre-electric mechanical engineering. You can climb onto the upper platform where the steady rhythmic rotation of sound and cascading water remain unchanged since Queen Victoria's reign. More than half a century later, the Laxey Wheel still performs exactly as it was designed to, powered by nothing more than flowing water and ingenuity. Number 12. The Strasbourg Astronomical Clock, 1843 to present. Inside the Strasbourg Cathedral is a masterpiece of 19th century engineering that still runs daily. The Strasbourg Astronomical Clock. It was completed in 1843. It's the third and most advanced version of a centuries-old project that dates back to the 14th century. The clock's purpose, though, is far greater than just telling the time. It displays astronomical data including the positions of the sun and moon, the phases of the moon, solar and lunar eclipses, equinoxes, and even the date of Easter, according to both the solar and ecclesiastical calendars. It also features automata, mechanical figures that move on the hour, depicting scenes like the apostles passing before Christ at noon each day. The designer, Jean-Baptiste Filguet, a Strasbourg-born mathematician and clockmaker, spent over 30 years designing the movement. He developed a gear system of nearly 100,000 components. Much of them still function today, and unlike purely mechanical clocks that rely solely on weights and escapements, the Strasbourg mechanism integrates astronomical gearing and calendar programming accurate to the year 9999. Now, remarkably, it still operates using the 1843 gearing escapement and astronomical tables. The movement does require weekly winding, a task performed manually to lift the large counterweights. And although minor restorations have replaced some worn brass bushings and iron pivots, the original mechanism remains operationally authentic. Each day at solar noon, crowds gather to watch the procession of the apostles and the striking of the automaton rooster, a spectacle that's continued almost unchanged for generations. It is the same working machine installed in 1843, still performing the same intricate calculations with amazing precision. It is proof that the pre-digital craftsmanship that we all take for granted today, when executed with care, can achieve longevity and accuracy far beyond expectations. More than 180 years later, this machine of gears and cams links the 19th century age of invention to our present day. Number 11. The Jenks Machine Works Steam Engine. Deep inside a preserved section of the Jenks Machine Works complex in Pawtucket, Rhode Island, is a steam engine that's been running for well over a century. Built in the 1890s, this large horizontal steam engine once powered the machine tools that produce equipment for New England's booming textile industry. It now serves as a working exhibit and a living relic of the industrial era. It's still operational on the same bearings, pistons, and flywheel that first turned in the 19th century. The Jenks Machine Works was one of the companies of the Blackstone River Valley. It was often described as the birthplace of America's Industrial Revolution. The engine there is typical of late Victorian industrial design, a massive cast iron flywheel driven by steam pistons through a crankshaft, with mechanical linkages distributing power to belt drives across the shop floor. The system originally powered looms, metal lathes, and milling machines through an overhead line shaft system that was basically a network of pulleys and belts that transmitted motion to every workstation. Now, while the factory's production stopped long ago, a group of preservation engineers and volunteers have kept the steam engine operational. It now runs on low-pressure steam generated by a modern boiler for safety, but the motion and sound are unchanged from the 1890s. The engine's lubricators, the valve gear, and the governor are all original. Periodic maintenance, oil cleaning, and inspection of the main bearings has been enough to keep it turning smoothly for more than 100 years. What makes this one extraordinary is not just the age, but the fact that it was never decommissioned or rebuilt. When engineers tested the tolerances of the flywheel and cylinder in the early 2000s, they found them within the original factory specifications. Today, demonstrations of this engine draws engineers and students and historians interested in mechanics of early industrial America. This rhythmic motion, the thick steel rods moving in synchronization remain a hypnotic reminder of the power of the 19th century craftsmanship. It's a rare survivor of an era when machines were built not only to function, but to last for generations. Number 10. The Peckett Steam Locomotive. The small but sturdy Peckett & Son steam locomotives built in Bristol, England, were once workhorses of Britain's industrial sidings and quarries. One survivor is the North Dorset, a Peckett 04-aught saddle tank locomotive built in 1913 that remains operational for more than 110 years. Unlike many restored museum pieces, the North Dorset continues to work under steam regularly. These locomotives were simple, heavily built, and easy to maintain, qualities that have allowed many of them to survive into the 21st century. North Dorset was originally delivered to a quarry in Somerset, where it hauled stone wagons for decades. It worked continuously through both World Wars, requiring little more than periodic retubing and boiler maintenance. After industrial steam operations declined in the 1960s, North Dorset was saved from scrapping and restored by volunteers. The locomotive was recommissioned in the early 1980s and it's remained in service ever since, hauling short tourist trains and demonstration freights. Routine inspections by the UK's Rail Safety Executive confirm that North Dorset does meet current operating standards, and it makes it one of the oldest regularly steamed locomotives still certified for mainline heritage operation in Britain. Visitors to the North Dorset railways can still see her under full steam, puffing white smoke and chuffing along short runs of restored track. This is an echo of the industrial past that has been brought to life. More than a century since it first left the Bristol foundry, the little Peckett locomotive continues to run exactly as intended. Its polished brass gleaming and pistons pumping in a rhythm. It's a demonstration of how careful engineering and dedicated maintenance can keep a 100-year-old machine in motion. Number 9. The James Watt Beam Engine, 1812 to present. At the Kew Bridge Steam Museum in London, now called the London Museum of Water and Steam, is one of the world's oldest operational engines that still runs, a beam engine designed to use principles pioneered by James Watt himself. Installed in 1812 at the Kinneil Pumping Station in Scotland and later relocated to Kew, this massive steam-driven machine remains fully functional more than 2 centuries after its construction. Its design uses a large overhead beam that transferred energy from a vertical piston to a rotating flywheel, driving pumps that supplied clean water to London. The immense iron beam, 10 meters long, rocks back and forth, each stroke powered by expanding steam inside its single 44-inch cylinder. Now, originally the machine was working continuously to lift thousands of gallons of water per hour. It was built to run for decades with minimal maintenance. That was a goal it clearly met. When it was retired from daily operation in the early 20th, engineers found the mechanism in still near-perfect condition. It was later restored to working order using low-pressure steam for museum demonstrations, preserving all the original cast-iron components. Every bearing, valve, and linkage still operates on 19th century principles, manually oiled and adjusted by hand. During special events, the museum engineers will start it up and visitors can see the same motion that once powered the infrastructure of Britain's capital. Even after 2 centuries, the original castings remain structurally sound and the beam itself still bears visible 1812 foundry marks. This James Watt beam engine at Kew is more than just a display. It's a living machine that continues to run under its own power. 200 years later, its measured rhythm and metallic sounds remind visitors of how the modern world was first powered by steam and machines built to last forever. Number 8. The Sächsische Maschinenfabrik Printing Press. In a small workshop in Leipzig, Germany, a city once known as the printing capital of Europe, an original Sächsische Maschinenfabrik letterpress from 1910 still operates. This manually fed, belt-driven printing press, designed and built by one of Saxony's most respected engineering firms, continues to produce fine art prints, using the same cast iron rollers and mechanical plates it left the factory with more than a century ago. The Sächsische Maschinenfabrik Company, based in Chemnitz, was renowned in the late 19th century and early 20th. The 1910 press was originally installed as a commercial print shop that served local publishers. When the business closed in the 1960s, the press was purchased by a master printer who preserved it and maintained it. Today, it sits in a workshop in Leipzig where it's used for demonstration and limited production printing, and it still runs on its original flywheel, crankshaft, and inking system. It operates through a foot pedal or electric motor, pressing metal type and etched plates against paper. Despite being over a century old, the tolerances remain pretty tight. That, of course, is an example of German industrial craftsmanship. Every motion is visible. The gears turn, the cams lift the plates, and the rollers apply ink evenly across the type bed. With regular oiling, cleaning, and proper tensioning of the belts, it can continue working indefinitely. The only parts that have been replaced are consumables, rubber rollers, and inking pads. Technically, the press has never really stopped running. It was used continuously from its installation until 1963, then intermittently through the Cold War, and again since its reactivation in the 1990s. The same iron framework that once produced thousands of newspapers now prints limited edition books, posters, and cards by hand. In an era now that's dominated by digital printers, this early 20th century letterpress is fully operational, powered by nothing more than mechanical motion and human rhythm. More than a century after it first stamped ink to paper, the Leipzig press still clanks and hums every day, quietly bridging the world of Gutenberg and the 21st century. Moving on to number 7, the Tower Bridge Hydraulic System, 1894 to present. When London's Tower Bridge opened in 1894, it was hailed as an engineering marvel. It combined a bascule and suspension bridge that could lift its enormous roadway. What made this possible was hydraulic systems powered entirely by steam. And incredibly, parts of the original system still operate today, making it one of the oldest continually functioning mechanical infrastructures. Instead of electricity, it relied on steam-driven pumping engines to pressurize the water, which was then stored in these hydraulic accumulators housed in the bridge's towers. When a ship needed to pass, the valves were opened and stored pressure forced the water through a network of pipes, powering giant pistons that raised the bridge 2 bascules. Each of them weigh over 1,000 tons, in just about a minute. For nearly 80 years, the engines ran on steam, but in the early 1970s they were converted to an electro-hydraulic system. But instead of scrapping the old machinery, the engineers preserved it. The original steam engines, accumulators, and control valves still reside in the bridge's engine rooms, fully functional and occasionally operated for demonstrations. Many of the steel pistons and gears date back to the 1890s, and their movement remains as fluid and as balanced as ever. Those slow-operating steam engines, the rotating flywheels, and oil-lubricated bearings have lasted because they were engineered to work under constant load with minimal stress. That's one of the key reasons all these mechanisms still turn smoothly more than a century later. Today, the bridge lifts about 800 times a year, about twice daily. While the power sources change, though, the essential mechanical principles remain identical to those of 1894. You can visit and see the original system firsthand at the Tower Bridge engine rooms, where the great steam accumulators and the giant flywheels are all visible, and they gleam with 19th century craftsmanship. The machinery no longer drives the lifts daily, but when tested, it still works exactly as it did when Queen Victoria reigned. Over 130 years after its construction, it stands as one of the few large-scale machines from the Victorian era that's still in practical use. Number 6. The Heidelberg Original Printing Press. Introduced in 1914 by Heidelberger Drucksmaschinen AG, this platen press, nicknamed the Windmill for its distinctive rotating paper gripper, revolutionized small-scale printing. More than a century later, thousands of these machines are still running around the world, and many of them are in daily use. Now, the original Heidelberg works on a simple principle. Sheets of paper are fed in one at a time by a rotating arm that resembles a windmill, synchronized perfectly with the opening and closing of the press platen. This mechanism applies even pressure across the type surface, producing a crisp, uniform impression at speeds unthinkable for hand presses. Early models could deliver more than 4,000 impressions an hour. That was an amazing feat for 1914. The tolerances were so tight that even after decades of continuous operation, the presses built before World War I often remain within factory specifications. Its durability comes down to precision German engineering. The frame is solid cast iron, resistant to vibration and distortion. The gears are hardened steel, and they're machined and hand-fitted by craftsmen at the Heidelberg factory. Operators often joke that the press only stops working if the owner does. During the 20th century, the presses became ubiquitous in print shops across Europe, North America, and Asia. They printed everything from business cards and wedding invitations to pharmaceutical packaging. Many survived both world wars, outlasting their factories and owners, and in some workshops, the same press has served 3 or 4 generations of printers. Even as offset and digital printing took over the industry, the Heidelberg windmill is indispensable for specialty work like embossing, foil stamping, and die cutting. These are tasks that demand the precision and mechanical pressure only a platen press can provide. And remarkably, Heidelberg still supplies parts and service for these 100-year-old machines, and collectors, of course, continue to trade them in working condition. At the company's headquarters, technicians do maintain several original Tegel presses from the 1910s that run daily demonstrations. They operate at near original speeds and are capable of producing commercial-grade prints. When properly maintained, a Heidelberg press can run indefinitely pretty much. Some printers have logged more than 80 million impressions on a single unit without even replacing any major part. And more than a century since its debut, it continues to run in print shops worldwide. It shows how awesome this mechanical design was. It embodies an era when machines were meant to last for generations. And in many cases, they still do. Number 5. The Harwell Decatron Computer, 1951 to present. In the National Museum of Computing at Bletchley Park, a room-sized computer built in the early days of digital technology still hums and flashes with life. It's known as the Harwell Decatron Computer, later nicknamed the Witch, the Wolverhampton instrument for teaching computing from Harwell. It is officially recognized by Guinness as the world's oldest working digital computer. It was built in 1951. This electromechanical machine still runs today more than 70 years later. It used thousands of mechanical relays, vacuum tubes, and Decatron counting tubes. These are small gas-filled cylinders that could display numerical positions as tiny glowing dots. When it's in operation, the machine produces these mesmerizing flickers of orange light across the front panels, and each pulse represents a mathematical operation in progress. Now, unlike modern computers, which rely on microprocessors, this one performs calculations mechanically and electronically at a human observable speed, about 1 addition per second. This deliberate pace was part of its appeal for scientists in the 1950s who could visually verify each step in real time. The computer stored data on punched paper tape and used relay switches for logic processing. Now, incredibly, it never fell into disrepair. It was used at Harwell until 1957, then transferred to Wolverhampton and Staffordshire Technical College as a teaching tool. It remained operational there until the early 1970s before being placed in storage. Decades later, engineers began a painstaking restoration using the original circuit diagrams, and by 2012 the computer was running again, exactly as it had in 1951. Every major component is original, from its 828 Decatron tubes to its electromechanical relays. The restoration didn't replace its logic or memory systems, only the wiring insulation that was refreshed for safety. It still processes data the same way it did more than 70 years ago. Visitors can watch the machine execute calculations, its relays clicking away rhythmically as the Decatron lights spiral in orange patterns. Unlike most early computers preserved as just static artifacts, this one is still computing in real time. Today, in an age of disposable technology, this 1951 computer continues to run exactly as intended, proving that even the earliest machines in the digital age were built with mechanical hearts that endure. Number 4. The Duryea Motor Wagon. One of the oldest internal combustion vehicles that's still running today is the Duryea Motor Wagon, built in 1893 by brothers Charles and Frank Duryea. Long before Ford's assembly line and mass production, the brothers constructed their automobile by hand in a Springfield workshop, creating what is widely considered the first successful gasoline-powered car in the United States. Astonishingly, one of their original vehicles still operates today, more than 130 years later. Now, it featured a single-cylinder 4-horsepower engine with 2-speed transmission and bicycle-style seats. The frame was based on a modified horse carriage, but the brothers' key innovation here was mechanical reliability. Unlike earlier experimental cars that could only run for minutes, the Duryea design started consistently and drove under its own power for miles. In 1895, the brothers entered their car in the Chicago Times-Herald race that was America's first organized automobile competition. The Duryea motor wagon won first place, beating the electric and steam-powered competitors in freezing November weather. This victory marked the start of the American automotive industry. But today, several of the original cars survive in museums, but one in particular, maintained by the Smithsonian, still runs. It's been restored mechanically, but it retains nearly all of its original components, including the wooden carriage body and brass fuel fittings. The engine still operates on the original compression system, and the steering lever, braking mechanism, and belt drive all function exactly as they did in 1893. The Smithsonian staff, though, does periodically run the vehicle at very low speeds to demonstrate its function, confirming that it still can start, idle, and drive short distances. There are other restored cars and private collections that have also been seen operating under their own power, some participating in historic parades. Man, more than a century later, the quiet chug of its little single-cylinder engine still echoes the beginning of the automotive revolution, proving that the first American car didn't just make history, it still makes motion. Number 3. The Poughkeepsie Ice Machinery Plant Steam Pump. On the banks of the Hudson River in Poughkeepsie, New York, there's a piece of 19th century machinery that has defied every modern assumption about durability. Built in 1873 by the Worthington Pump and Machinery Corporation, this massive steam-driven water pump installed at the old Poughkeepsie Ice Machinery Plant has been running, in one form or another, for more than 150 years. The Worthington Company was among the leading innovators of its time. They're famous for building the high-pressure pumps that supplied New York City's earliest waterworks. When Poughkeepsie plant opened in the early 1870s, ice production was entering its mechanical age. Before electric refrigeration, ice was harvested naturally from frozen rivers and lakes, but factories like this one were beginning to use compressors and condensers to produce ice year-round. That process required an enormous and constant supply of cold water, and for that, they turned to Worthington's engines. The steam pump at Poughkeepsie is a direct-acting duplex pump, meaning it consists of 2 steam cylinders and 2 water cylinders arranged side by side, each set driving the other in synchronization. Steam enters one cylinder to push its piston, which simultaneously draws water into the other, alternating back and forth in a balanced rhythm. This design eliminated the need for a crankshaft and a flywheel, which reduced mechanical wear and tear, making the system self-starting. It's one of the reasons why it lasted so long. Each stroke of the pistons moves roughly 500 gallons of water through cast iron pipes that are nearly as old as the building itself. The room where the pump operates still has the marks of the era, the soot stains on the brick walls, riveted steel beams that are blackened by decades of steam, and hand-forged valves that open with heavy brass handles. The Worthington engineers of the late 1800s designed these machines to last not years but generations. The pistons are balanced and polished to within thousandths of an inch, and the cylinders were lined with an alloy that resists any corrosion. The valves were shaped for self-seating even under uneven loads, and the heavy cast iron frame weighs over 20 tons. It absorbs vibration so effectively that the machine runs almost silently despite its size. When the plant was decommissioned in the mid-20th, the pump was left in place. While other equipment was removed or scrapped, local preservationists recognized its value and ensured that it remained operational. They replaced a few corroded pipes, cleaned decades of grease and scale from the joints, and connected it to a small, modern boiler to allow low-pressure operation. When they fired it up, it began to move almost immediately. The slow strokes of the pistons and the faint hiss of escaping steam returned it to life as if no time had passed at all. Today, the pump is run a few times a year by volunteers under the supervision of the Hudson River Maritime Museum, and each startup is a ritual. The lubrication lines are cleared, steam lines are tested, and the safety valves are checked by hand. When the engine starts, the great piston rods begin to glide with the same smooth precision they had when Ulysses S. Grant was president. Visitors describe the experience as hypnotic. It's the sound of steam expanding and contracting in rhythm, with the motion of iron that's been alive for a century and a half. Number 2. The Solar Railway and its electric locomotives, Majorca, Spain. Running through the mountains and valleys in Majorca since 1912, the Solar Railway is one of the few electric train systems in the world that's still operating with the original locomotives, track layout, and power system. Stretching for about 27 kilometers between the island's capital and the coastal town of Solar, this narrow-gauge railway has run daily for more than a century. The whole line was conceived in the early 20th century when the people nearby needed a way to transport oranges and olives from their valleys to Palma's markets. Construction began in 1907 under local engineers, and after 5 years of labor through steep terrain, the line opened in 1912. Just 2 years later, it became one of the first railways in Europe to convert entirely to electric traction. Each of the locomotives operates with a classic 4-motor configuration, controlled by hand-operated rheostats and mechanical braking. Their top speed is pretty modest, it's around 40 kph, but they have remarkable endurance, pulling carriages up to 1 in 36 gradients through 13 tunnels and across numerous viaducts. The line's centerpiece, though, the 2,800-meter Solar Tunnel, remains one of the longest hand-dug railways still in active use in Europe. For over 100 years, these trains have almost run continuously. Even during the Spanish Civil War, service was only briefly interrupted. Through 2 world wars, political upheaval, and waves of modernization, the Solar Railway maintained its independence. When the plant was refurbished in the 1980s, engineers found that much of the original 1910s-era machinery, generators, transformers, and switchgear, was still serviceable. Unlike modern mass transit systems built for maximum throughput, this line was engineered for durability. The mechanical controls required no complex electronics, and the locomotive's motors could be serviced entirely by hand. Spare parts are custom machined in the railway's own workshops using original blueprints, many drawn on ink and linen sheets that are stored in the depot archives. But the best part is, every morning before the first train departs Palma, engineers perform the same startup ritual that their predecessors did a century ago. The traction motors are checked, the oil reservoirs filled, and the brake system tested. When the driver closes the circuit and power surges through the copper lines, the distinctive hum of the motors fills the station. It is an identical sound to what passengers heard in 1914. The train then glides out of the depot, gathering speed as it climbs into the mountains, the smell of oiled wood and warm metal filling the air. Number 1. The Voyager spacecraft, launched in 1997 and still operating in deep space. So this is amazing. More than 15 billion miles from Earth, 2 machines built by human hands are still running, transmitting faint radio signals across the void after nearly half a century. These are Voyager 1 and Voyager 2, twin spacecraft launched by NASA in 1977. They were designed to last just 5 years, and they've been functioning for almost 50. Their instruments are still gathering and transmitting data from interstellar space, the first and only human-made machines to have left the sun's magnetic bubble entirely. Each carries a suite of scientific instruments, magnetometers, cosmic ray detectors, plasma sensors, and cameras, along with 3 onboard computers, a 3.7-meter dish antenna, and a small nuclear power source called an RTG, or a radioisotope thermoelectric generator. When they launched from Cape Canaveral in 1977, engineers here expected them to last through a brief, grand tour of Jupiter and Saturn, maybe Uranus and Neptune if all went well. Instead, they've outlived their designs, the original computers, and nearly every spacecraft built since. Voyager 1 completed its planetary mission in 1980 after returning to the first close-up images of Jupiter's swirling storms. Voyager 2 followed, becoming the only spacecraft to ever visit Uranus and Neptune, and after those flybys, both spacecraft continued outward, their trajectories carrying them into the uncharted realm beyond the planets, and by 1990 they were more than 4 billion miles away from the Sun. On Valentine's Day that year, at the request of astronomer Carl Sagan, Voyager 1 turned its camera back towards the Earth, and it captured the famous pale blue dot picture, an image of our planet suspended in a beam of sunlight less than a pixel wide. By that point, their cameras were shut down to conserve energy, but their other instruments kept working. For decades afterwards, the Voyagers continued to measure cosmic radiation and magnetic fields. In 2012, Voyager 1 became the first spacecraft to enter interstellar space. Voyager 2 followed in 2018, both still transmitting data through the Deep Space Network. These are radio signals that take over 22 hours to even reach the Earth. The fact that they're still alive is nothing short of miraculous. Those RTGs, powered by radioactive decay, produce less electricity every year, and in 1977 each generated about 470 watts. Today, they deliver less than half that. Each command sent to a Voyager has to travel 15 billion miles, taking nearly a full day to arrive there. The radio transmitters are less powerful than a refrigerator light bulb, yet the signals they send are picked up by the Deep Space Network's massive 70-meter antennas. The data rate, which is barely 160 bits per second, is slower than even the earliest dial-up modems, but it's enough to deliver scientific information from beyond the solar system. NASA engineers who maintain contact with the Voyagers describe them as stubbornly alive. Every few months, the team uploads new command sequences, carefully managing power and adjusting antenna angles to keep communication stable. The engineers that work on them have to think in hours, not seconds, and any mistake could take a full day to detect and another to correct. But even after nearly half a century, they remain surprisingly healthy. Their main communication systems are stable, their instruments continue to function, and their structural integrity appears flawless. Yet the end will eventually come, not from failure, but from energy loss. By around 2030, their power output will fall below what's needed to operate any instrument, and the last of their transmitters will shut down. After that, they will continue silently into interstellar space, still powered by the radioactive decay of their plutonium cores, their antennas pointed towards the stars. It is really difficult to overstate what these two machines represent. They were built with slide rules, soldering irons, and analog circuits. They were launched before personal computers, before the internet, before cell phones. Yet they continue to work in an environment no human technology was ever tested for. The Voyager missions remind us that not all endurance is mechanical. Some of it is philosophical. These things represent a kind of optimism that technology can create something that lasts longer than ourselves, machines that transcend their purpose and time. That alone makes them unique among all human creations. They will keep traveling, unbroken and untouched through the interstellar dark. A pair of machines built for a few years that have already lasted a lifetime and will continue to outlast us all.